So what's up mga kachimek? We're done with the three different gas laws. So to have a short recap, we have the Boyle's law, Boyle's law, and then we have the Charles law, Charles's law, and then the Gay-Lussac's law. So here in the three different gas laws, we are talking about the same amount of gases in a container. So here in the Boyle's law, we have the formula P1 is equals to P2 V2. This is at constant temperature, and again at constant number of moles or number of molecules of a gas. Charles' law, we have V1 over T1 is equals to V2 over T2. This is at constant, very good, constant pressure. And then Gay-Lussac's, lastly, we have the pen not working anymore. Let's try a blue one. That's pressure. Okay, it's not working too. So we are not all working. That's pressure over temperature. P1 T1 is equals to P2 over T2 at constant. What is the constant? Volume. Very good. Now take a look at these three different equations. What can you notice? Sige. Have a few seconds. Very good. No, each one is lacking, no, or meaning is relying on one specific aspect. No, here pressure and volume is given, but the temperature is constant. Here volume and temperature is given, but the pressure is constant. Here we have pressure and temperature at constant volume. So one very nice scientist by the name of Benoit Paul Émile Clapeyron, I don't know if I pronounce it correctly, basta it's Clapeyron, realized that these three separate equations discovered from three different periods in time are actually the same, or they're actually talking about the same single equation. So that is why this gas law is very magnificent. But this is not yet the final equation. So he called this equation, 'di ba? Sobrang talino ng nagpangalan, no? Sinawag niyang combined gas law. Naubusan na siya. Ayaw niyang ipangalan sa kanya, or maybe the scientific community don't want to name it after him because he simply combined three separate laws, 'di ba? Three different scientists in three different times talking about the same thing. Just how amazing is that? First, Clapeyron realized that yes, it's true that pressure and volume are inversely proportional, while the pressure and temperature are directly proportional, so as V and T. So this is constant. Now, if you notice, we can rearrange the formula into PV over T with this as the initials and P2, V2, and T2. And what's magnificent here, it's a big hurrah, it's a big eureka for the scientific community during Clapeyron time, because this summarizes all the equations at constant number of gases, at number of moles, so at constant n. So meaning there's no longer a constant volume. It's okay if the temperature is not constant. It's fine if the pressure is not constant, because they are all in the same single equation. So say for instance, I try to cover the temperature, and there I have the Boyle's law. I try to cover the pressure, I have the Charles law. And if I cover the volume, I have the Charles law. So it does not disobey, it does not contradict any of the three single equations that we have discussed a while ago. And that's why this discovery, is a milestone for the scientists, combining the three different gas laws. And as I've mentioned, maybe on some of my discussion, the goal of the scientific community is to create a single unified equation that would explain everything, If you're familiar, Einstein and Stephen Hawking has been trying to work on these equations, na the theory of everything, one single equation. And later on, after the Avogadro's and ideal gas equation, you will realize how beautiful this is. That's why I'm getting excited. But before we proceed any further, of course, we will try to use this one in an example. Alright, so the formula for the combined gas laws is simply the mixture, no? The combination of the three different laws, that's P1 V1 is equals to T1 is equals to P2 V2 over T2. So here we have a lot of given. So this will be a long, tedious process, but this is as easy as eating a piece of cake. So I don't know if I get the correct idioms there. So anyways, say for instance, a certain balloon, which is 2 liters, 2.0 liters, has an initial pressure of 1.2 atm. Favorite ko si 1.2. And then it has a temperature of 32 degrees Celsius. All right. Suddenly, the temperature drops to 27 degrees Celsius. And of course, since the temperature dropped, the volume also decreased, to 1.9 liters. So what would be the final pressure in the container? So what would be the pressure of the balloon, the P2? So let's label this one. This is your V2. This is your T2. This is your T1. This is your P1. And then this is your V1. So using the equation, we have to get rid of V2 and T2 to isolate P2. So let's manipulate the equation first. Since I have a space, so I might start here. I divide both sides by T1, T2, or multiply rather. T1, T2. T1 would cancel out. T2 would cancel out. I'll be left with P1, V1, T2 is equals to P2, V2, T1. And then, to isolate P2, I divide both sides by V2, T1, V2, T1. This will cancel out. I'll be left with P2 is equals to P1, V1, T2. Hopefully, I've followed V2 over T1. Now, before I proceed with the substitution, I have to first change the units, especially of the temperature. So this becomes 32 plus 273. That's 305 Kelvin. 27 plus 273, that's 300 Kelvin. That's my T2. Now I can simply substitute. P2 is equals to, my P1 is 1.2 atm. Then my V1 is 2.0 liter. My T2 is 300 Kelvin. And my V2 is 1.9 liters. And then my P1 is 32 degrees at 305 Kelvin. Cancel the unit, liter, Kelvin. I'll be left with atm. So my P2, let's use the calculator. So kindly solve with me. That's yan. Local lang calculator ko, so I have to input it. 1.2 times, what's that again? 1.2 times 2.0, or simply 2, times 300 Kelvin, 300 Kelvin. That would be 720. So let me write it here first because I don't have, yan, 720 Kelvin. And then I have 1.9 times 305. That would be 579.5. So here I still have ATM, 579.5. So that would be 720 divided by 579.5. That would be 1.24 ATM. So the answer would be 1. Bakit laging 1.24 nakuha? 1.24 ATM. So the pressure would be 1.24 ATM. And there you have it, the combined gas laws. Again, if you want to solve another problem, if you want to try some more, we have in our handout, no, and yeah, later on I'll be uploading some practice problems as well. So I will no longer give you a problem in here. So just try to solve and practice in your own using our handout. So you simply cover the answer first and then try to solve the problem. Alright? So thank you so much, mga Chimek. Next time, we'll be talking about the Avogadro's law and one of the most elegant equation in the universe, no? The ideal gas equation. And there you have it. Thank you so much. Have a great day.